If you do not practice using this question that I am about to cover in this video, there is no way to mark the progress that you have made in Euclidean geometry. There is no way that you will be able to determine whether you have been improving or whether your understanding has constantly been declining. Okay, and so this question is so important to cover. This question will give you guidance on what you need to work on and what you are strong at. So it will give you it will outline the areas your weaknesses in Euclidean geometry and your strengths in Euclidean geometry. And it's very important to approach these questions and to use these questions while practicing for your math exam or for Euclidean geometry, because it will give you an idea on what you should focus on, what you should focus more on, and what you should pay less attention to. Okay, so without further ado, let's get started with the video. Question 10 in the figure, two circles intersected A and B. So we have AB produced to M bisect QAR, tangents MQ and MR meet the circles at Q and R respectively. QBR is a straight line, and then AQ and AR are drawn. Now, the very first thing is we obviously have to read the information in the segment above, okay? And I would like to split this video into two parts. The very first part of the video, I will be doing a structural analysis on the diagram, and in the second part of the video, we'll be answering the questions thoroughly. Let's look at the information in the segment. AB produced to M bisects QAR. QAR. What does it mean when a line bisects an angle? When a line bisects an angle, it means that that line splits that angle into two equal parts. And so in this case, QAR is bisected. It's AB produced to M refers to this angle over here, bisects QAR. Okay, so this line, the line that stems from M, bisects AQAR, meaning that A has been equally divided into two equal parts. It's been split into two equal parts, meaning that A1 equals to A2. Okay, and that's very important to remember. And so what do we do with that information? How do we annotate our diagram using that information? And so what we have to do is we have to annotate A1 and A2 using corresponding colors. Next part of the question. Tangents MQ and MR meet the circle at Q and R respectively. Now, the next thing that you want to do is if there's any mention of tangents, you need to draw or you need to create a list of all the theorems that are applied to tangents. And so that's what we're going to do. Now, what are tangent theorems? Tangents from the same point, tan chord theorem, tangent perpendicular to radius. Those are the three theorems that are related to the tangents, So those are all three tangent theorems. And so let's continue on. Now, the next thing that we want to do, the next step to the process is we are going to highlight MQ. Okay, so that's what we're going to do. I am going to highlight MQ, which is that down over there, and you want to highlight MR. Now, let's first start off by evaluating or trying to identify and see if tangent from the same point is applicable. So we can clearly see that we have MQ, that's a tangent, MR is also a tangent, and they meet at the exact same point. And so we definitely know that tangents from the same point will be applicable to this question, meaning that MQ will be equal to MR because of tangents from the same point. Now, as a result of us marking MQ and MR as being equal to each other, we've consequently identified an isosceles triangle. The isosceles triangle that I'm referring to is triangle QMR. Now, if we have an isosceles triangle, that means the opposite interior angles from the sides that are equal to each other will equal to each other, okay? And so we just want to mark them off as being equal. So we know that Q1 will be equal to R1 because of opposite angles equal sides. And so let's continue on. We want to see if the tan chord theorem is applicable to this question. Now, when we are working with the tan chord theorem, we have to identify the tangent and we have to identify the chord. Okay, so what you want to do is you want to take your highlighter, identify the tangent. Let's first start off with MQ. MQ is our tangent, and then let's identify our chord. A chord is a line that carves different segments out from a circle. So it's just a line that carves different segments of a circle, carves out different sections of a circle, creating a segment, okay? And so we can clearly see that QB is a chord. Identify the angle between the chord and the tangent. That is the second step to the process. The angle that is between the chord and the angle is Q1. The third step to the process is to identify the angle that the chord subtends. How do we identify the angle that the chord subtends? This is exactly what you're going to do. Here's what to do. The very first thing you want to do is you want to take your pencil and trace the lines from both ends of the chord all the way to the other end of the circumference of the circle. So let's start doing that. I'm going to start, ends over here, do the exact same thing on the other side, trace it, it ends over there. And so we can clearly see that QB subtends A1 because the line or the angle between the two blue lines is A1. And so we know that QB subtends A1. Okay, so the next thing that you want to do is you want to mark them off as being equal to each other. We know that A1 equals to Q1 because of our tan chord theorem. Now, let's continue on with the next tangent. We want to evaluate and interpret the tangent's relationship to the entire Euclidean shape, or its relationship to the chord. Now, MR, you want to break down the chord theorem. Tan chord, it involves a tangent and a chord. Our tangent in this case is MR, our chord is BR. The next thing you want to do is you want to identify the angle between the chord and the angle between the tangent. The angle between the chord, which is BR, and the angle between the tangent is MR, is R1. The third step to the process is you want to identify the angle that the chord subtends. How do you identify an angle that a line subtends? This is exactly what you're going to do. Take your pencil, trace the lines from each end of the chord all the way to the circumference of the circle. Trace it. It ends right over there. Do the exact same thing on the other side. Trace it. It ends over there. Meaning that R1 will equal to A2. R1 equals to A2 because of the tan chord theorem. Now, let's continue on. We've identified the fact that the tan chord theorem is applicable to this question, and we've identified that the tangent from the same line is also applicable to this question. Now let's continue on. What about the tangent perpendicular to radius theorem? Now, in order for this theorem to be applicable, in order for us to annotate our diagram according to this theorem, we need to identify a tangent and a radius. However, we do not have a radius present. Why is that? Well, that's because we do not have a center present in the diagram. And so if we do not have a center present in the diagram, we cannot have a radius. Why is that? Well, because the very definition of a radius is that it is a line that stems from the center and touches the circumference of the circle. And so if you do not have a center, it means you can't have a radius present. So now let's continue on. Now they tell us that QBR is a straight line, AQ and AR are drawn. Now, it looks like we have completed our structural analysis of our Euclidean geometrical shape, okay? So before you continue on with the questions, it's very crucial to first conduct a structural analysis, interpreting different parts, different segments of the diagram, evaluating the different shapes that form a part of the diagram. And so in doing this, what you're doing is you're training your mind to evaluate and to identify different parts of the shape and different segments of the shape that you otherwise would not have seen if you did not conduct a structural analysis with the annotations, obviously. And so before we continue on with once you've read all the information in the segment, you do need to identify a few more other theorems that might be applicable. Any theorem that has to do with the cyclic quads, so you first have to identify any cyclic quads that are present. I'm pretty sure you're thinking that QARM is a cyclic quad. Well, it is not a cyclic quad. Why is that? Why is it that it's not a cyclic quad? Well, because a cyclic quad is a four-sided shape in which all four sides touch the circumference of the circle. And so we know Q and A touch the circumference of the circle. We know that R touches the circumference of the circle. However, M does not do that. M does not touch the circumference of the circle. And so that fact completely disqualifies it from being a cyclic quad. Now, what are the other few theorems that we want to identify that may be applicable to this question? Something that we want to remind ourselves of. Sum of angles of a triangle, exterior angle of a triangle, angles on a straight line, vertically opposite. Okay. And so you just want to write a list of all the other miscellaneous theorems that might be used to your advantage while covering the questions. Okay, everyone, thank you for watching this video. Hopefully it was helpful. Just like I said previously, I would like for everyone to accustom themselves, to become accustomed to the idea of conducting a structural analysis before continuing on with answering the questions. If you just immediately start off with the questions without conducting any form of analysis, without warming yourself up to the question, without reading the information in the segment, without making any annotations, without identifying any angles that have a direct link to each other, without identifying the angles and marking them off with corresponding colors, you will fail in understanding Euclidean geometry, and Euclidean geometry will become your worst enemy. You will hate it with everything. And so hopefully you enjoyed it. Now, please make sure to watch the next video. Make sure you understand exactly how I've conducted the structural analysis, and part two to this video will be coming up. You can just click onto the next video. Without further ado, I will see you in the next video.